And good morning, or good afternoon, or good evening, wherever you are in your day. We're starting lesson 4.6 today. The title or the objective is to understand slope-intercept form. Please do these warm-up problems, and we'll come back and check our answers. We're finding each y-intercept, 1 and 2, finding each slope, 3 and 4, and solving for y in 5 and 6. So for 1 and 2, we see the y-intercept. If x were 0, this term cancels, y equals 2. In number 2, we're going to have to let x equal 0 again, and we have negative 3y equals 12. Slope is simply the coefficient to x. Over here, in this case, we have to solve for y first. Notice this is in y equals mx form. This is direct variation. This one is standard form, and we need to isolate y. So we're going to subtract 6x and divide everything by 2. Solving for y, we subtract 4x from each side and divide by 2. Dividing everything by 6, we get 3 over 6, or 1/2 x, and 2 over 6, 1/3. Objectives for the lesson today are to write linear equations in slope-intercept form and to be able to graph the line using slope-intercept form. It's one of the simplest forms that we have and that we deal with. You've seen that you can graph a line if you know 2 points. Another way is to use the slope of the line and the point that contains the y-intercept. So we have seen that we can graph a line if we know 2 points. We can plot those points in the coordinate plane and then connect the dots. Another way is to use the equation of the line when it's in slope-intercept form. Graphing the line given, the slope and the y-intercept, here's our slope, negative 2/5, and our y-intercept. Our first step is to plot the y-intercept. Because it's on the y-axis, x is 0. We take the slope then, the change in y over the change in x, that's given to us in fraction form. We're going to be going vertically down 2 and horizontally over 5. So we plot our point, the y-intercept, 0, 4, and we use our slope, rise of negative 2, run of positive 5. And we connect the dots by drawing the line through the 2. That sounds easy. You try. Check it out. It says graph the line, the slope, and the y-intercept. Slope is 2. Now keep in mind this is rise over run. What would that run have to be? If we turn 2 into a fraction, it would be 2 over 1. And our y-intercept is negative 3. The y-intercept, if we plot that first, the point is 0, negative 3. And our change in y is the 2 given, but our unknown, or the one we have to think about, is the change in x. Any whole number is always over 1. So we count 2 units up and 1 unit to the right, and we've got our second point, and we connect the dots. So easy. You guys try, check it out, 1B, and come back and check your answer. So it says to graph the line given, the slope and the y-intercept. Slope is negative 2/3, and the y-intercept is now 1. We think in our minds y-intercept means the point 0, 1. The change in the y is 2. Change in the x is 3. One of them's negative. And they've chosen to give the rise the negative value. Only one of them gets it. This is negative 2, but positive 3, giving us the negative value for our slope. Drawing the line through the points, this is what your graph should look like. If you know the slope of a line and the y-intercept, you can write an equation that describes the line. So now we're going to kind of move backwards. If a line has a slope of 2 and a y-intercept of 3, then m is 2 and 0, 3 is on the line. Substitute these values into the slope formula. We know that the slope is 2. Here's our equation for slope, and we're going to subtract the y value. It's y minus y over x minus x, and we get the following. Solving for y, Simplifying the denominator, x minus 0 is simply x. We're going to multiply both sides of the equation by x. On this side, we see that it cancels. We get 2x equals y minus 3. Adding 3 to both sides, we get y equals 2x plus 3. We've now placed the qualities of our line into slope-intercept form. Slope-intercept form of a linear equation, this is good for your notes. If a line has slope m and y-intercept b, then the line is described by the equation y equals mx plus b, our y-intercept. Any linear equation can be written in slope-intercept form by solving for y and simplifying. In this form, you can immediately see the slope and y-intercept. Also, you can quickly graph a line when the equation is written in slope-intercept form. Let's try this. Writing linear equations in slope-intercept form, it says we're going to write the equation that describes the line that we have here. Our slope is 1/4 and our y-intercept is 4. Keeping in mind this is our m and this is our b. Substitute the given values for m and b into this form, slope-intercept form, y equals mx plus b, and then simplify if necessary. We have y equals m, our slope that was given to us, and b, our y-intercept that was given to us. Let's try it again. Write the equation that describes this line in slope-intercept form. We have a slope of -9 and a y-intercept of 5/4. Substituting those values back into our simple form of the equation, y equals -9x minus 5/4. And we're done. Couldn't be easier. And now you guys think back. If we were to graph this line, we're going to plot our y-intercept first and then use our slope to get to the second point to graph. Let's write the equation of the line seen here. Well, we know that we need m and we need b. Let's start with b, our y-intercept. We can locate that point to be +3. So our y-intercept will be 0, 3, or b equals 3. We can use our slope formula to calculate slope, or we can simply count up 1 over 2. We have a rise of 1 and a run of 2, and we can see that, simply put, they get a slope of 1/2, and our equation, our value for b is 3, 1/2 x plus 3. Take time, get this down into your notes, and understand the steps. Let's write the equation that describes this line. Our slope is 2, and the point 3,4 is on the line. Well, we don't have a y-intercept now, but we can certainly find it. We're going to find the y-intercept by writing the slope-intercept form and substituting this time our m value and our x and y. We're going to solve for b. Let's see how that's done. We're going to substitute 2 in for the slope, and the x value from our point is 3. Our y value is 4. We're going to substitute those in. Subtracting 6 from both sides, we see that b is -2. Now we have a slope of 2 and a y-intercept of -2, and we're going to put those into our equation, and we are done. 2x minus 2. This gives us our line. If we want to graph this, go backwards, we would plot the point -2, that's our y-intercept, and then we would rise 2 and run 1 to get to our next point. You try, check it out. 2a says write the equation that describes each line in slope-intercept form. Come back and see what you get. So we are given the slope -12 and our y-intercept of -1/2. We're simply going to substitute those values into our nice, neat, tidy equation in slope-intercept form. Our -12 is our m value. It's a coefficient to x, and our y-intercept is -1/2. That's our slope, our y-intercept. Let's try this one. Write the equation that describes this line in slope-intercept form. Well, we can see the y-intercept is 0. We might think back to our days of discussing direct variation. We know that in this case a slope of 1 indicates 1x, and we don't have to write that. That's understood, and the plus 0 does not have to be written. This is our parent function in the linear form. So let's try 2D. If a line has a slope of 8 and a point that it passes through, negative 3, 1, write the equation that describes this line in slope-intercept form. Work out the problem and come back and check your answer. So first thing we're going to do is bring up our equation of the line, y equals mx plus b, but this time we know we have m, x, and y, and we're going to be solving for b. So we're going to substitute our values in. Slope is 8, x is negative 3, y is 1. X is negative 3, y is 1. We're going to substitute those in and simplify. Negative 24 plus b, we're going to add 24 to both sides, solving b equals 25. Substituting back in, now we have m and b. We're going to substitute our slope in, y equals 8x plus 25. And that is slope-intercept. Let's look at 3a. Using slope-intercept form, we're going to graph the line. It says to write the equation in slope-intercept form, and then graph the line described by the equation. Well, we're going to extract what we need from our equation. It says that our slope is 3. Remember, that whole number indicates over 1, so we're going to rise 3, run 1, and our y-intercept is negative 1. We're going to start with that. We're going to plot our point, 0, negative 1. There's our dot. And then we're going to use our slope, 3 units up, 1 unit to the right. Both are positive. And we're going to draw our next point there and connect the dots. In example 3b, it says, let's do this again. It says write the equation first in slope-intercept form. You can see that it's in standard. And then graph the line. Remember, we're solving for y. We have to get y isolated on one side of the equation. So we're going to add or subtract first. We're going to subtract the term 3x. And we're going to divide by 2, yielding our new equation, y equals negative 3/2 x plus 3. We're going to begin by plotting our point, our y-intercept, 0, 3. And we're going to use our slope, negative 3, positive 2. We're going to go down 3 and over 2 to plot our next point. Connecting the dots exposes our line. So we see the slope of negative 3/2. We should definitely see a trend or a slope of negative in our line after we graph it. Try check it out, 3a. Come back, check your answer. So moving through this one quickly, we see that we are in direct variation again. Y equals 2/3 x. This is our constant of variation, 2/3. And we see that our y-intercept is 0. Notice the point at the origin, 0. We move up 2 and over 3 to get to our next point. Drawing the line, this is what you should have come up with for check it out, 3a. Try this one. 3b, write the equation in slope-intercept form and graph the line. Here we go. Write the equation in slope-intercept form. So we want to isolate y again. We're subtracting 6x. That's our first step. Dividing by 2, yielding our equation, y equals negative 3x plus 5. We've got our y-intercept and our slope. We're going to take that to the next page and use that information. We're going to plot our y-intercept first and use our slope of negative 3 over 1. Counting down 3 and 1 over, we're going to create our new point and connect the dots. Congratulations, you're done.